Okay, g'day guys. Thanks. Just in the last few minutes, we've had quite a few more joins. So we'll kick off. So guys, just to introduce myself, I'm Doug Meldrum. I look after sales for SolarEdge here in Australia, and joining me today is James Sturch, our technical director. And I guess we're running this webinar really for those who couldn't make our recent roadshow at the capital cities. And so it'll go for about 45 or 50 minutes, and you'll notice on the function there on the side panel, there's a chat function. So by all means, if you've got questions as we're going, please type away. Brent Heber, our colleague, will respond. But at the end of the session, which will go for about 45, 50 minutes, we'll open it up for Q&A. So what I'll do is, to get started, I'll turn my camera off just to maximize the screen, and thanks for joining, and we'll take you through the session. Okay. So I guess as a quick agenda, guys, to go through, we're going to do a little bit of a recap on why DC optimization in the first place. Why even consider putting an optimizer on every panel? We'll then take you through a lot of the new products that we've just brought to market, in particular our three-phase storage solutions. And then James will take you through a lot more of the technical elements around the configurations of those storage solutions. We'll talk a little bit about SolarEdge Go, our new, I guess, installer app, which combines setup for commissioning, but also the monitoring portal and functions of our service capabilities. And we'll talk a little bit about SolarEdge One for CNI, which is more of an enhanced monitoring suite for larger systems. And we'll also just take you through the recent promotions, so you're across the latest that we're doing. Okay. So I guess why optimize systems in the first place? You know, what does it do? I think one of the things we've been asked a lot as a business is we talk a lot about optimizing the system to get more energy and dealing with issues, whether it's through the mismatch that arises from soiling, different orientations, or what have you. And we've been asked many, many times is to put a figure to how much more you actually get. And one of the recent studies that we've done in the last year is we've taken 500 Australian systems, and that had SolarEdge on there, all across the country, different configurations, single or dual string, and they had to be systems that a string inverter could also support. And what we did is modeled how a string inverter would behave in that configuration on those roofs. And basically, you know, through the modeling, we came out with 6 to 10% more energy from a traditional system. It was an inherently conservative analysis in that we set the voltage at a fixed point, where normal string inverters operate with variable voltages. So we fixed the efficiency, but we also set it at our 99.2% efficiency, which is generally a lot higher than traditional inverters. So we try to make it really conservative. And I guess, you know, but what does this actually mean for the homeowner? So if you model this out, taking 30 cents a kilowatt hour, CPI at 3% over the life of the system, and so we take it out to 25 years, it works out at $500 extra savings per panel for the system over its life. But if we bring that back to, say, the ROI period of around 5 years, on a 10 kilowatt system, that's $2,500 in extra savings that a homeowner would receive if they went SolarEdge. And that pretty well covers the delta that we see with many string systems today in the market. So I guess it's a classic case is you pay a little bit more at the start, but you get a lot more over the life of the system. I guess, how does it achieve this? You know, really what we're looking to do is, by adding an optimizer, you're effectively putting a PowerPoint tracker on every module. And, you know, if we look at traditional string inverter systems, is they just don't have the resolution of being able to control individual panels on the roof, because there's only a single tracker per string. And so should there be a poor performing module, whether it be through manufacturing tolerance, effects of heat and time, soiling, configuration, orientation, inclination, whatever it might be, is they're unable to isolate poor performing modules within that string. And the optimizer is able to do that. So not only does it allow the best performing modules to perform at their peak, but also isolate poorer performing panels, whatever the reason might be, from bringing down the rest of the string. And that has a significant impact over the life of the system. But that's only one element of where you get higher yield from a SolarEdge solution. So just a quick schematic here, looking at the principles of operation. You know, we fix the voltage going into the inverter, but that's not the case with a conventional string system. Based on irradiance, the voltage will vary. But I guess one of the key points that some of our friendly competitors out there will use against SolarEdge is that a common concern is more points of failure. I guess we like to look at it as more points of detection or redundancy. And if you think about it, there's still the same amount of panels connected in the system. But what traditional string systems can't do is look for the telltale signs of an arc occurring, so spikes in temperature at the connection point. Should there be an issue at that connection point, is send an alert to let you know that panel 3 on string 2 has a problem. Should a problem occur, is to actually isolate that panel so that it prevents a potential arc fault, but it also allows the rest of the system to continue operating at its maximum output. And I guess, you know, so equally, having an optimizer can be used in a positive sense, and really using it as a way to ensure that systems are safe, and should there be a fault, that they continue operating at their maximum output. I guess the other key principle or operating advantage that we have is because we do run at a fixed voltage of about 380 to 400 volts for residential, is that the inverter, our DC coupled batteries, and soon our DC coupled car chargers all run off a common DC bus. And it drives a few things. So firstly, it allows ease of expansion. So whether it's adding a new string of panels of a different make or type, because the string operates at the same voltage regardless of length or module type, is that we can then parallel more strings. And you might want to do that if you're adding extra batteries and you need more panels for charging batteries, or extra panels for charging cars. And it's a significant feature that's often overlooked at the time when someone is starting out their solar journey, doesn't want a battery, looking for solar only, is they discount, I guess, the features or the needs that they might need to consider when adding a battery in the future. And too often we see AC coupled systems where the batteries are permanently undercharged because there's no scope to expand that current system that's on site unless you scrap it, which is a costly activity. At least with this, we have that flexibility to expand systems easily over time. I think the other key element that we need to consider is the optimizer, is the inverter efficiency. One key advantage of operating a fixed DC voltage is that we're running at the sweet spot for DC to AC inversion. So provided there's enough irradiance, the optimizers with their boost function are able to lift voltage in the string very, very early in a day's operation, or very late in a day's operation, and have the inverter running at 99.2% all of the time. Now, that's not the case for traditional string or microinverters, where a certain operating voltage must be reached that's linked to the irradiance. They have no ability to buck or boost. And so as clouds come and go, things change, the seasons, shading, so forth, is that variable voltage does bring down the efficiency of the system. So again, when you think of the 6 to 10% we gain through dealing with module mismatch, there's more layers of extra output that we get with inverter efficiencies. They all combine to drive far greater savings for homeowners, which is really the key reason why solar's installed in the first place. So just touching quickly on the DC coupled nature of our batteries. I guess one of the beauties with optimizers and being able to add extra panels for DC charging is that any surplus energy is captured and stored in the battery should it require charging. And I just wanted to show a schematic or a screenshot from our My SolarEdge app. And here's a classic example where it's showing a system with a nameplate capacity of 11.7 kilowatts, actually delivering more. So it's a cool, sunny spring morning in Sydney. You've got a car charging at full power on the AC side. You've got a depleted battery that's charging fully in the morning, and there's some loads in the home as well. And overall, we're seeing the system actually generating more power. So a couple of things are going on is that the AC and DC sides aren't competing. So the batteries are getting its full level of energy that it needs to charge quickly. You've got the optimizers which provide headroom. So should the irradiance conditions be suitable, the panel will deliver more than its, I guess, nameplate conditions that you get under standard test conditions. And it really does provide that flexibility that we see with homes as, you know, we start to gear up where more panels need to be added to meet those energy needs of the future, particularly with cars and batteries. And I guess I'm just going to move through this quickly, but this also is a worked example comparing the differences between traditional DC coupled hybrid technology and that which we see with our own systems. So again, we run at fixed voltages, and because the battery charges at the same voltage as that which is generated on the roof, it's extremely efficient. And it's quite different to that which you see with traditional DC coupled hybrid inverters, where there's some sort of voltage management or step down or step up effect, which can be nearly as inefficient as a DC to AC inversion step like we see with AC coupling. But ultimately, what it all boils down to is up to an extra 30 days of battery use with SolarEdge, or conversely, it's wasted up to 30 days worth of battery use on traditional systems. So, you know, when you're talking with customers and they're thinking about where do they spend their hard-earned dollars on a solar system, you know, trying to sell something that's a little bit more expensive at the start is harder, but really helping them understand where the benefits lie and putting some monetary value around that is really critical. I'm just going to step through these. I think I've touched on a lot of these points. The ability to do uneven strings, multiple orientations. We can mix different power in the string. We can also mix different optimizers to accommodate different panel types in those strings. So that ability to expand over time, whether it's actual extra strings or extending strings, is something that we can do. It's also safer. I think we all understand that typical string inverters, if there's a fault condition with the inverter or the grid, the sun's out, you know, those DC wires are live with very high direct current voltages. Microinverters do have an advantage. They're up on the roof, so should there be a fault with the inverter or the grid, they're safely tucked away underneath the panel. But you know, it's not necessarily the same as our solution, where the optimizer literally drops the panel's output to 1 volt per panel. So if there's 10 in the string, there's only 10 volts DC. And you know, we feel that's probably the safest solution you can have, particularly when you combine that with our SenseConnect capabilities, being able to detect the temperature anomalies that lead to arc faults in MC4 connections, and there's plenty of them on the roof. So, and I guess here's a couple of areas where safety is critical. A flood, so the inverter's compromised, it's underwater, but the panels are fully irradiated. And in a similar scenario like this, where there's significant damage from hail, bright sunny the next day, you know, it's difficult to control those DC voltages with traditional inverter systems. So I guess, guys, just quickly, just as we step through, you know, why optimizers? At the end of the day, homes need more energy, and SolarEdge delivers more energy from every panel, you know, and it's at least $500 extra savings that a homeowner gets each panel over the life of the system. And I guess using that as part of your sales argument to help address any price objections or concerns over upfront cost, you know, these savings easily cover the differences that we see with traditional inverters in the market. So, you know, after 3 to 5 years, you're ahead and stay well ahead. Not to mention the added safety, the added versatility of the system in the future, but also the added visibility. Having an insurance system and knowing how your panels are performing over that life of that system is really important. Okay, so why optimize this? We're going to just talk quickly now on some of the new products, and James will take you through a little bit more detail. I guess we're now really starting to round out the key elements of our system. So not only optimizing what happens on the roof, being able to manage sending that power really efficiently, whether it's to batteries or cars, and to maximize savings while you're doing it. But as we start to bring our full range of smart energy devices to the market, is being able to intelligently manage that remotely or with schedules. But most importantly is doing this wirelessly, is getting away from wired infrastructure, which introduces cost during installation, but also sources for faults later in life where connections or start to come loose. So our new home network technology, it's based on mobile phone mesh network technology, really starts to link together now the battery and the inverter, but also the metering and other device controllers, whether it's the hot water or appliances. So they're really starting to have a significant effect on not only the homeowner's experience, but we hope your experience as an installer, getting away from running expensive cabling. I guess to address a bit of an elephant in the room, I think it's fair to say our older model HD wave inverters haven't behaved or performed as well as we'd like. And one of the things that we've invested a huge amount of time in the last couple of years is rebuilding the inverters completely, but also the firmware to help control, I guess, the voltage spikes that we're seeing that drive, potential flaws in the system. So first thing we did was redesign the internals of the inverter. We moved to automotive capacitors. So these are capacitors that are produced to a far higher tolerance and have a much greater ability to handle voltage spikes that we see with the Aussie grid. We've also, redesigned the way the boards are done, and also new voltage control firmware. And we're seeing a significant improvement in the product's performance over the last couple of years. And if for those of you who've maybe had a bit of a tough run at times and have been sort of shied away from SolarEdge, we hope you're experiencing some of these newer inverters and seeing them perform well. But certainly the data we've got so far suggests they're going really, really well. Now, some good news, I guess this was long awaited, was finally integration of the home battery with our residential three-phase inverters. So I guess a couple of key things on this application. There's no backup with this model, and there never was. It's not like the home hub inverter. It lacks a lot of the hardware to deliver backup. But like our Genesis inverter, it will accept DC battery connection for maximized self-consumption applications. And but if you've got homeowners out there who, when they get a battery and still want backup, we are still running the trade-up program where any three-phase inverter can be swapped out to a home hub. And we do have some backup solutions for multi-phase sites, which James will talk about in a minute. So just with regard to this integration, it's live now. It covers all of the residential three-phase inverters from 5 to 10 kilowatts. But it is just single battery connection per inverter at this stage, and also just standard DC oversizing to 135%. So they're just key things to remember. But I guess with many, many thousand of these inverters in the field, oversized to 133%, this integration really does bode well for those customers of yours that might have bought this as a battery-ready system. And now this can accept a really simple connection, no different to a home hub. The only key elements you need to remember is that battery communication must be EnergyNet, so wireless, no RS485 at the moment. And please make sure yourself or your Sparkies just have updated SetApp, so they've got the latest firmware, which now supports this combination. Now, we will be doing work to increase the range or configurations that this inverter will support. So that includes increasing the oversizing as much as we can. We don't think it'll be able to go as far as home hub or Genesis because it is a different inverter, but we'll validate that as quickly as we can. And we'll hopefully see the ability to parallel multiple batteries shortly as well. And just as a quick reminder, if there's any of you out there who haven't had a lot of exposure to our current range of residential three-phase inverters, it's not like the old ones. They have very, very similar design guidelines with minimums like our single-phase units, including running single string design for 5 kilowatts, where you can put 14, 15, 16 panels in a single string. Okay, moving quickly then just on a couple of elements on our smart switching. So there's two types in the market. There's our smart switch and the load controller. So this first one, the smart switch, is the most recent addition to the portfolio. And this is really designed for small loads. It's a true just on-off product. The power supply is wired through the unit. It has a little inbuilt meter, and it's there as a really convenient way for homeowners to control small air conditioners, small pool pumps, smaller loads with an on-off feature. Now, that's not to be confused with the load controller, which can operate in a similar manner, but is really designed to work in conjunction with a contactor to support the programming of running much larger loads, so greater than 3 kilowatts. So, you know, big pumps, big air conditioning systems, non-essential loads. And I guess the beauty with this, with both of these units, is that when a battery with backup is installed, is that you can elect or deselect these particular appliances to run whilst the system is in backup, thereby preserving battery energy. So there's some nice features. So the load controller, think of that for using a contactor to remotely power really large loads, and the smart switch is for direct control of smaller appliances. And I guess with both systems, we have the ability for manual control, setting schedules, running them in excess PV only, but also being able to turn them on and off when running in backup. Okay, now that marks the end of my section. I will hand over duties to my colleague, James, who will take over. So thanks for listening to that section.
Great. Thanks a lot, Doug. So yes, I'm going to run through with you some of the technical configurations. Now, the first one, as Doug mentioned, is the integration between our three-phase residential inverter, that's the SC5K-AUB through to the 10, and the SolarEdge home battery. So when we integrate them, the first thing, just to, you know, it's kind of teaching you to suck eggs really, but make sure everything's turned off. And also make sure to use the supplied MC4 connectors to wire the DC coming from the battery. Now, there's a couple of different options on how you can do the wiring, really around the fact that this could be an add-on or a battery being added to an existing installation. If so, then you've already got the DC coming down from the roof to the inverter. So you'll need to join the DC to that DC because the three-phase Resi inverter's only got a single DC input. So you need to bring them two together in the DCD. Alternatively, if it's a new install, what you can do is you can bring the DC straight to the battery and then use one of our branch connectors and then use the single input into the battery. A nicer, simpler way to do it. I mean, you could do this with an existing install if the DC cable allows. Also, as Doug mentioned, EnergyNet is the mandatory communication protocol. What is really important is to understand the fact that the residential three-phase inverters may have two different communication cards in them. So one is basically got a single comms board slot on it and the other one's got two. Because of that, there are two different EnergyNet cards. As you can see there, one is the EnergyNet or ENET HBNP-01 and the other is the HBCL-01. The simple way to approach this is if the card in the inverter can take the small EnergyNet card, use that one. If it can only take the big one, use that one. What you cannot do is put the big one onto the board which has got the 2 ports on it. The reason being is that it wasn't designed for it, and it actually the battery terminal is much larger and it can cause communication issue with that board. Now this is only really a problem for existing installs which were put in sort of over 2 years ago. All current inverters since then have got the dual boards, so they'll take the small Enginet cards. So all new installs, this isn't going to be an issue at all. If you're going to add a battery onto an existing install, the advice is basically just to take both sets of cards with you, and that way you know to install the appropriate one. Because there's a battery, now having a meter also becomes mandatory, because the inverter needs to be set up in MSC function, so maximizing self-consumption. The meter obviously needs to go in the main switchboard. You can wire the Modbus meter RS485 or the inline meter RS485, or that can also communicate over Energynet. And when it's all commissioned, just make sure it's obviously in import-export configuration. And then once it's all in, I mean, that really is the wiring and setup. Then just go through the normal turning everything on procedure, and then commission it through setup. So it is really, really simple now to add those batteries to those 3-phase inverters. What we also have the ability to do now, which is really exciting, is allow backup on the 3-phase properties using a polyphase backup switchboard. So what this product does is it allows for backup on dual or 3-phase properties. It requires a home hub inverter and a battery and a backup interface. And like I say, it supports all of the single phase loads. It doesn't support any 3-phase loads, which is kind of okay, to be honest, because most of the 3-phase loads, they're the heavier loads which don't really necessitate being used in backup to help the extension of duration in backup. And the system can be expanded. You can add batteries, you can add additional follower inverters to the system as well. It helps to really overcome backup supply limits, especially with 3-phase hybrids, because the output is not limited by the fact that a lot of hybrid inverters have difficulty with the asymmetry of being able to supply loads. And there's an awful lot less work to do in the switchboard. It creates a lot less headache for installers. So I'll just flick through these ones. So basically, as you can see there, single home hub inverter, and then got a couple of followers, either Genesis or home hub. You can then have inverter capacity between 5 and 30 kilowatts. PV system can be from 6.6 to 66 kilowatt peak, and storage capacity anywhere between 10 and 90 kilowatt hours, which is fantastic. The mode of operation is quite simple, really. You've got your 3-phase supply, which goes to your distribution board, which then supplies the 3-phase loads. And you've got your 3-phase supply going to the polyphase backup switchboard, which then supplies all of the single-phase loads. So that's your L1, L2, and L3. You've then got single-phase supply going to the home hub inverter, and single-phase supply going to the backup interface, and then a comms connection between the backup interface and the home hub inverter. Obviously, the home hub inverter needs to have a battery on it, and then if you want, as I just mentioned, you can have additional inverters with additional batteries. Those all set up as followers. What I will come to in a minute is exactly how that is wired, because it's slightly different to a lot of the configurations that people are used to. So that's on-grid operation, super simple. When the grid then fails, we lose the 3-phase supply to the main distribution switchboard, which then cuts the 3-phase supply to those 3-phase loads. The 3-phase supply is then taken away from the polyphase backup switchboard, which then in turn cuts the AC to the backup interface. Now what that then does, it registers the fact that the grid has failed. It sends a signal to the home hub inverter, which tells it to change its function from grid following to grid forming. So it becomes a backup inverter. And at the same time, you can see there that either side of the polyphase backup switchboard, the phases are now bridged together. So there's no longer L1, L2, L3. There is just one single combined single phase connection. The transition times for all this is probably worth pointing out. So the backup interface, as it is got a transition to off-grid of between 2 to 3 seconds, something like that. When the system then goes back to being on grid, there's a transition time of 5 seconds. The reason that is there is that when those single phase load circuits want to reconnect to the 3-phase supply, you need to ensure that they're fully de-energized so that when they recombine, they connect to the correct phase angle. So wiring it, obviously the DC, just like I explained with the 3-phase, the ideal is you bring the DC to the battery, use the branch connectors, and then go to the single DC input into the inverter. Now, if you were to have multiple batteries, you can just do the same. You can just use the branch connectors to link them all together. So super simple. The AC cable size is important. So it's recommended that the distance between the polyphase backup switchboard and the main switchboard is 20 meters, and use 25mm cable for your actives and actives and neutral with a 16mm on the earth. The polyphase backup switchboard is 63 amp rated, but the reason that cable is the size it is to allow for the system operating in backup. So the home hub inverters, if you've got a 10 kilowatt inverter there, you've got to be running about 45 amps in backup. So you've got to make sure that there is sufficient cable size for the earth fault loop impedance, basically to be able to get back to the main MEN connection, which is still retained in the main switchboard. So once that's wired, you then wire the AC between the backup interface and the polyphase switchboard, and we can see there on the diagram, really important, you're only wiring the grid connection, you're not doing anything with the loads. And because that's really just there to do voltage reference, you can just use 2.5mm cable for that. The comms in there is just as you would do normally, you just don't worry about wiring the CT. Then you've got the AC connection between the inverter and the polyphase backup switchboard. Again, if it's a 10 kilowatt home hub, the recommendation is about 10 meters and to use 10mm CSA cable to make sure that your voltage drop isn't too great. Now, as the system is now going to be installed on a 3-phase supply, you need 3-phase metering or 3-phase AC connections to the metering. The meter inside the home hub inverter is only wired in single phase. So to connect your L2 and L3 terminals, you just take off the little plastic cover on the terminals and then just wire in the other phases. You then obviously need to wire the 3 CTs in the main switchboard. They can be extended if you need to using Cat6 cable. Alternatively, to make life super simple, you can just use the inline meter, the 3-phase inline meter, and connect that if you want to do through RS485 or just use EnergyNet. So if additional inverters are going to be connected, they need to be wired in leader follower, like I've already explained. So what's really important there is that when you're creating the RS485 daisy chain, that the leader, the home hub inverter, is terminated and the final inverter is also terminated, so that the whole daisy chain is complete, so that the system knows where it begins and where it ends. And then if you wanted to, obviously you can add additional batteries onto those inverters as well. And then just go through the normal process. You just basically turn everything on in the order which makes sense, and then just commission as usual through setup. So nice and straightforward. Then wiring the loads. So the loads can just be wired straight into the main switchboard if they were quite simply able to be segregated to the 3 phases, or alternatively you can just wire directly to final distribution circuits or to a subboard. What is worth pointing out is that the PBS, the polyphase backup switchboard, doesn't have any RCDs or RCBOs in it. So if you are wiring straight to a final distribution circuit, you can just swap those MCBs to an RCD. So what this all leans to with the backup solution is the fact that we now can offer multi-day backup. You know, this is something which is really unique in terms of our ability to be able to keep supporting loads for so long, especially with the Black Start functionality. So what the Black Start does, I mean, some people are familiar with Black Start, but just to kind of give you the nuts and bolts of it, if you're in grid failure and you're running off your battery and the battery then is fully depleted in the small hours, the system will then, for all intensive purposes, shut down. As soon as the sun comes up the following day, it will then start the system, it will start to charge the battery, and once the battery has met a minimum state of charge, it will then start to supply the AC loads. And that process can keep going almost indefinitely. But let's say there was something happened and the actual battery will be able to stay in that pre-black start function for 20 days in itself. So it really does extend the duration of backup with SolarEdge systems. What else is coming quite soon is the new fast mount solution. So this is quite a lovely product because it's really going to help make installations way easier and also look an awful lot neater. So we showed this at All Energy last year. It's a connector which sits underneath the inverters, or it could be an inverter and backup interface, and it comes with all the different glands, and it basically allows for all those cabling connections to be housed in one place. It also allows for the DC, so if you can use those branch connectors, you can put those in there as well. It really is just a space, a cavity to make installers' lives easier. And like I say, it makes installations look a damn sight neater than rather than having, flex conduit all over the place, making it look like, I don't know, something really ugly. So they will be with us. We're hoping to get those released towards the end of this year, as well as a slightly different range of our existing branch connectors, ones with fuses in it, to help with systems where you've got lovely amount of oversizing, where there may be 3 or more strings where you need to have overcurrent protection, which looks like this. So these are some illustrations here to show you how the fused branch connectors work to be able to combine your strings. And then also if you've got multi-strings and multiple batteries, how you can bring everything together into the single input into the inverter using fused connectors or non-fused connectors if need be. They should be with us again about the same time as the inline, as the fast mount. Another interesting development is SolarEdge Go. So basically SolarEdge Go replaces Setup. It combines Setup, Mapper, and the monitoring all into a single app. This is now in general release in Australia. So go to the App Store, download it, and have a play about with it. It is a fantastic improvement on the current system and current setup, mainly for the reason that it allows a lot more functionality. I'll just flick through these because the real game changer is that you can connect to systems. Where's the one I really want to show you? Because the slides are going slow. No, it's too slow. So what you can now do with Go is you can remotely connect into the system. What this means is that you can do commissioning not on site, or you can get into a site without needing to be standing next to the inverter. So if you just think about that practically, you can install the system, set it up to do the firmware updates, and leave site. You can then that night or the next morning jump back into the system and finish off the commissioning, because sometimes firmware updates, they might take half hour, 45 minutes or whatever, and you just want to get off, or it could be the end of the day and there isn't enough PV generation to kick in all the optimizers to do the pairing. So it is an absolute game changer for us, SolarEdge Go. It also has other features which are now coming through setup. So there's a installer wizard, which basically commissioning wizard, which gives you step-by-step prompts through the process, and other features in there as well to really make life an awful lot easier. We've also created some other improvements into the actual commissioning process, such as rapid pairing of the optimizers. And what's also going to be coming through reasonably soon is the way in which you can commission a system. You don't have to wait for everything to complete before you go to the next step. You don't have to wait for the optimizers to complete pairing before you go to the next step. You can do everything all at the same time. So you can set off the optimizer pairing and then go to setting up your grid codes or whatever. So again, it's really trying to help speed up the process for installers. We have some New exciting products also coming to Australia, hopefully next year, middle of next year. I'll just give you a quick sneak peek onto those. The first one is the TerraMax inverter. So this is our new CNI inverter. It's a 330 kilowatt inverter. It's primarily designed for ground mount systems. It is a really high efficiency CNI product. You can see there the CEC inverter efficiency 99%. It runs at 690 volts on the AC side, so it does need a transformer, but that's common for inverters of this size in the CNI space. So that is a really, really exciting product. Again, because it's just like some of our other products, that allows for 200% DC oversizing. To accompany that, then there's the H1300 power optimizer. That's specifically designed for the 330k TerraMax inverter. 15 amp output, so 20 amp on the output, so really does help to make those strings much easier to install, also with our super high 99.5% efficiency. And then we're also going to be introducing our commercial storage system. So this is a very nice all-in-one solution. It's actually got HVAC built into it as well to really keep the system running cool and be super efficient. They come 92 kilowatt hours, so that's 50 kilowatt inverter capacity, and these can be scaled up to a megawatt. IP65 rated for outdoor use and 10-year warranty on that. There's also a backup interface unit with that as well, so it's not just storage in its own right, it also offers backup. What is also interesting, just a quick sort of side note for anyone thinking or anyone operating in that CNI space, is that there's been a lot of developments recently from insurance companies. So FM Global, Zurich, Aon, they are all now actually specifying that any PV system installed on their buildings has to have MLPE installed. So that is inverters and optimizers that have the ability to be able to control the DC bus. Zurich specifically actually called out SolarEdge. So be aware. So this is something that is coming through to Australia ahead of safety standards and the like, where insurance companies are now getting much more concerned about the safety risks of non-MLPE solutions. SolarEdge One for CNI. This is a new, it's an all-in-one everything platform for the CNI space, for our commercial systems. So this is a new monitoring and management and system management platform. Like I said, it's dedicated for CNI, but what's really clever about it is it's actually a platform which you can make work for you in terms of you can create it how you need to use it. So you have fleet management option, so you can look at your entire fleet, or you can create your own fleets, or you can look at a single system. So, and then also within that, you can create fleets based on different characteristics. So if you want to look at a fleet that just got batteries on them, or if you want to look at a fleet which has got EV chargers on, you can segment them in that way. And then you can start doing a huge amount of analysis. You've got a much more involved dashboard, I would say, that's got a lot more information on there, but some of the real key information that you want to see. And there is, from the basic dashboard as well, you can look at a lot more of the specifics about the energy flow of the system, how it's working, where the energy is coming from, where it's going to, and some of the parameters. There's a year's worth of data in this that you can drill down to really be able to get a good view of how the system's operating. When you then get into the analysis side of systems, what's really cool about this is, unlike the current monitoring system, when you start looking at analysis and looking at data, you are limited by the amount of feeds you can have on the graphs. On this, you can get feeds from as much of the data sources on site as you would like and create your own bespoke graph. So you can have that data represented however you want, which is a really, really cool ability to be able to tailor make the solution to meet your requirements or the requirements of your customers. You then look at the devices in a much more granular way. You can get right into them. You get a lot more prompts and guides. You get visibility of actually what the products look like, and you can see live information on how the systems are actually operating. And it also helps tremendously with any kind of fault finding or looking at alerts, and you get prompts on how to troubleshoot alerts. But the real game changer in this platform is a function called the digital twin. So what the digital twin is, and I'll just show you this, is a way where we basically combine mapper with layout. So we create or give you the ability to have 3D views of the system. But what's unique about this, it's not just a nice, visual tool. This has live telemetry feeding it. So this is actually live values of what's going on the roof, on the optimizers. So you can use this to look at yield. You can use this to troubleshoot and find faulty optimizers. You can use this as a fantastic tool to be able to guide installers to exactly the location of products which might need to be looked at. It might be a failed optimizer or a dodgy panel. You can also then overlay a heat map, which again is unique. It's a fantastic tool to be able to really be able to hone in on if there are issues, or also just be able to use this to really understand how the yield works. As Doug mentioned early on, our ability to be able to harvest or maximize harvesting based on our ability to get everything out of the module. This, you can see it visually, because you can look at an array which should be the same, and you can look at the different outputs per module. You also still have the logical layout view in there as well, which helps to be able to just ensure that you understand exactly how things are strung. But this tool is awesome, and it really, really is a huge game changer for us, and it's really going to make installers and fleet operators' lives an awful lot easier. And now I will hand back over to Douglas.
All right, thanks, James. All right, guys, we're just in the home stretch now. So a couple of things just on promotions before we open it up for Q&A. Okay, so we've got a few promotions running at the moment. Firstly, the residential optimizer promotion that's running through our distributors. So it's been expanded to include S500. In fact, we've even put the older P505 optimizer in the mix as well, and it'll run out till the end of the year. So you've got plenty of chance and scope to either get out there and use it as a way to bring down the cost of optimizers by a third, or hang on to the margin. Either way, we don't mind. But that's just been expanded to be hopefully give you a little bit more range with the sorts of panels and system types that this can be applied. Now, equally is the commercial optimizer promotion. So we had one that was running that was a cashback and was really focused just on our P-series optimizers. That cashback promo was just being wound down as we speak, but it's been replaced with this one, which is more generous. And like the residential, it's buy two, get one free. And it includes all P-series optimizers that are left in our distributor or our own inventory here in Australia. But it also covers the new S1000 and S1200 optimizers, but it does exclude S1400, which has literally just come into the market, and we're still starting to build up inventories. But certainly it covers 98% of what we are currently or have been selling. So again, it's through distribution, and we hope you can really take advantage to make your SolarEdge commercial system more attractive to your client. Now, on the battery side of things, running in New South Wales only at this stage, it's just commenced, but it's really there to help you work with homeowners to address I guess the stalling of their decision of whether to go with a battery or not, and wait till the New South Wales government rebate kicks in on November 1. So, it may or may not start November 1. We don't know what all of the conditions are going to be in terms of entitlement, whether there's, means testing on salaries, those sorts of things. So I guess when you combine this homeowner cashback with some of the other promotions we've got running, they really do add up to significant discounts on SolarEdge systems. And if we look at trade up in particular, so for those of you with existing older model SolarEdge systems, it's a great time to go to the homeowner, because if you're swapping out an inverter, putting on a Home Hub 10, and in the homeowner's eyes, it's about $3,000 of extra value just there. But then whack the cash back on top. It's a really nice bit of value that the homeowner can get. So we hope that you can get on board and start using that to close deals, because that's live now and runs till the end of the year. And then, as I mentioned, with TradeUp, it's still running. We've gone through our 3-phase storage solutions. So for those people who are happy just to add a battery with our residential 3-phase inverter, the AUB model, then great. Those inverters will accept this battery. But if they're pre-2020 models, they can't work with this battery, and so TradeUp is your best option there. And likewise, if the homeowner wants backup with their battery, TradeUp is also your best option. But as we saw with that polyphase backup switchboard, we now have the ability to support backup on dual or 3-phase systems with our home hub inverters. So hopefully, again, those switchboards are now in stock at our distributors, and yeah, we hope that might also help you close some deals as well. Okay, so look, guys, just to close out from our side, I guess firstly, we've had a lot of feedback over the years, that SolarEdge is complex, that its tools are clunky, it's disjointed, going from being on site to coming back to base to adding sites to the portal, all of that. So, a lot of focus that we've done is helping address those concerns of installers and the operations side of the business have had. So whether it's just speeding up pairing with optimizers, having everything in a single app, we really, with SolarEdge Go's now fully live, we hope you really feel those time savings and enjoy it. I think also, is addressing the gaps in the portfolio. Although we don't have a true 3-phase hybrid with backup, we hope what we've presented today, at least, there are some distinct advantages versus other technologies in the market, but it allows you, I guess, to address any concerns and compete with our solutions in the market, particularly until our next generation product comes late next year, early the year after. And I think ultimately, when we think about in a tough economic environment at the moment, where cost of living is splashed all over the news, and in many areas of the market or society, people are really constrained and suffering a little. I guess it is a little harder to sell a product that has a higher capital outlay with the optimizers. But I guess with devices that add capabilities, you do get some back, and a lot of that is actually a lot more energy and far more savings for the homeowner, not just now, but for the entirety of the system's life. And we hope, in the coming months, as we bring out more content around this, is that you can really use that in your sales pitch to help, win business and, really give your customer a solution that, really does generate a lot of extra energy and maximizes their savings. And I guess, the key element for us also in addressing gaps is providing you with product that is way more resilient and far higher, reliability than what we've seen with some of our older models. And we hope you're starting to really experience that, particularly with the Home Hub and Genesis inverters. They're doing very well. So guys, I've just put a QR code up on the screen. So if you click on that, not only will we send you the presentation, but for those of you who would like to claim CPD points, you will, it'll take you through a link to register. You do have to do a test, unfortunately, with the new SAA body that drives a lot of this, the CPD point and the registrations. But you will get 15 points for completing that test. And yeah. So guys, I guess with that, we'd like to thank you for joining. And we hope you've got something out of this session. And, if we don't see you or talk to you in the very near term, we hope you come and see us at All Energy, as we'll have much of what we've shown to you today on display, and we can take you through it in a little bit more detail. But we'll also open it up to the panel now, that if you have any questions that you want to put in the chat, we'll try and answer them as best we can for you.
I think we answered everything amazingly, which is why there's no questions.
All right, we'll just give it another minute just to see if there's anything there. But look, if not, guys, you know, hit up either James or myself or your state manager and or our distributors, and the guys will be able to help you out as best as they can. And again, you know, look, thanks for joining us today and giving up your valuable time, and we look forward to talking to you shortly. Thanks very much.
Thanks a lot.